Okay, so today we're going to look at section 2.2, part 2, still analyzing conditional statements. So we're going to start out with a review of the original condition, the converse, the inverse, the contrapositive, and then the biconditional. We're going to look at using symbols as well. Okay? So remember that the original condition, what comes after the if is the hypothesis, what comes after the then is the conclusion. So here we would say if P, then Q. And you can see the symbols, okay? The arrow means then. So if P, then Q. The converse, remember, is where we swap places with the hypothesis and the conclusion. So then it would say if Q, then P. And again, you can see over here with symbols, we have traded places with the P and the Q. The inverse is where we take the original condition and we add the word not. So this would say not P. If not P, then not Q. And again, in symbols, you can see the little squiggly mark. That means not. So if not P, then not Q. The contrapositive, we take the converse and add the word not. So if not Q, then not P. And again, you can see in symbols, the little squiggly line. If not Q, then not P. The biconditional, okay, is if and only if, right? And so P, if and only if, Q. And I should say if, sorry. And so then in the symbols, we have the arrow going both conditions. So if P, then Q, okay, if and only if. The original condition is logically equivalent to, the original condition is logically equivalent to, remember that is the contrapositive. And the converse is logically equivalent to the inverse. So remember that means if we know that the original condition was true, then we automatically know that the contrapositive is true. If we know that the converse is true, we automatically know that the inverse is true, and vice versa if they were false. So let's start out with the statement. Points in the same line are collinear. So we want to turn that into a conditional statement. So we would say if points are on the same line, then they are collinear. And then we want to identify, is that true or false? So if points are on the same line and they are collinear, that we know is true. So then the converse of that is where we would trade places with them, the hypothesis and the conclusion. So then we would have if points are collinear, then they are on the same line. And again, we need to identify that as true or false. Okay, again, that is a true. The inverse, so remember this is where we go back to the original and we put not. So it's the if points are not on the same line, then they are not collinear. Collinear. And again, we want to identify, is this true or false? Again, this would be a true statement. And the contrapositive, we take the converse and we put the word not in. So this would say, if points are not collinear, then they are not on the same line. Points are not collinear, then they are not on the same line. And again, we need to identify that as true or false. Again, that is true. So then our next statement that we're going to look at, okay, they give me the statement. two complementary angles of a sum of 90 degrees. We want to change that to a conditional. So this would say if two angles are complementary, then they have a sum of 90 degrees. And we want to identify that as true or false. Again, that would be true, because that's what complementary means. Adds together to equal 90. So then we want the converse of that. So again, we just trade places with the hypothesis and the conclusion. So this would say if two angles have a sum of 90 degrees, then they are complementary. And again, we need to identify that as true or false. Again, that is true. So now it's asking me, is the inverse true or false? It's not asking me to state the inverse. Right? It just wants to know, is the inverse true or false? Well, I know that the inverse is also going to be true. And then it's asking me about the contrapositive. And I also know that the contrapositive would be true. And it says, why didn't I have to check the actual statements to see if the inverse and contrapositive are true or false? Remember that they are logically equivalent to one another. So that reminds us. So if the original and the converse are true, then the contrapositive and inverse are true. All right, so then let's go to the back and look. In geometry, when all four versions are logically equivalent to each other, like we just saw, the original statement is considered a well-written definition or a valid definition. And then it says example, what was true for all four versions because it defined what term. Okay, so we go back to here. We saw that our very first example was true for all four of them. It is defining the term collinear. So example number 1 was true because it defined the term collinear. And then it says example number what was also true because it defined what term. So then if we go back and we see that statement number 2, we knew was all going to be true as well. Then what were we defining? We were defining the term complementary. So here this is example number 2 because we defined the term complementary. Here's a way to indicate that the original and converse are in fact true. So P, if and only if Q, or our shortcut, let's try and fix those for you. P, if and only if, so remember we can, instead of writing out the words if and only if, we can put IFF, or we can use the mathematical symbol. Remember this is the equal sign with arrows on both directions. And recall from Friday that this condition, okay, this version is called a biconditional. This is where basically you get two conditions for one. So you get two conditionals for one. So we're going to start out with example number 3. It says an angle is a straight angle if and only if it measures 180 degrees. So they gave me the biconditional and they want me to write out what was the original statement. So my original statement would have said if an angle is straight, then it measures 180 degrees. And then it's asking me, is this true or false? Well, that's the definition of a straight angle, so that would be true. The converse, okay, is where I swap places. So if an angle measures 180 degrees, then it is a straight angle. And again, it's asking me, okay, is this true or false? Again, I know that this is true. Sorry. And then it's asking me, how do I know that? Right? Why? Because it's the definition of a straight angle. And then it says, why didn't we bother checking the inverse and contrapositive as well? Again, we know that if the original is true, then the contrapositive is true. And if the converse is true, then the inverse is also true. So example number 4 says, if a triangle is equilateral, then it has 3 congruent sides. Okay? So what does equilateral mean? Equilateral means equal sides. So if a triangle is equilateral, then it has 3 congruent sides. That is true. So then the converse of that, we just trade places with the hypothesis and the conclusion. So this would say, if a triangle has 3 congruent sides, then it is equilateral. And we want to know true or false. So again, we could say that that is true. Since my original turned out to be true and my converse turned out to be true, that means all 4 of them are going to be true. So then I could write it as a biconditional. So my biconditional would say a triangle is equilateral if and only if it has 3 congruent sides. All right, so let's look at example number 5. It says if you're playing for the BHS volleyball team, then you're a volleyball fan. Is that true or false? We would hope that would be true, that if you were playing for the volleyball team, then you're a volleyball fan. So we're going to say that's true. The converse, if you're a volleyball fan, then you play for the BHS volleyball team. Well, that's going to be false. I'm a volleyball fan, but I don't play for the volleyball team. Okay, so then biconditional, okay, I cannot write a biconditional because they were not all true. Okay? So we would say there's none. Okay? And again, this is an opinion, not a fact. Okay? Again, it was my opinion that we are assuming that if you're playing for the BHS volleyball team, then you're a volleyball fan. But if you're a volleyball fan, then you're not necessarily playing for the volleyball team. Okay, so we could not write a biconditional for that. So then we want to know, what are the 2 conditionals implied by the biconditional? Okay. So the product of 2 numbers is negative if and only if the numbers have opposite sides. So what's one way that the conditional could have been written? So this could have said, if the product of 2 numbers is negative, then the numbers had opposite sides. The other way that I could have written that, I could have traded places, because remember, if it's a biconditional, it doesn't matter which came first, the hypothesis or the conclusion. So I could have also said, if 2 numbers have opposite signs, then their product is negative. So that's just a quick recap of the conditional statements, the converse, the inverse, and the contrapositive, and then a little bit more time with the biconditionals that we talked about on Friday. So that wraps up section 2.2.